So, ladies and gentlemen, I'm very proud to welcome on stage Florian Heese. He will talk about element call to you and show you the latest shit? No, shit is the wrong word here. The latest development of a Matrix RTC client by Element. Give him a warm welcome.
Hello. Thanks, Jan, for the nice introduction. No pressure. I'm Florian. Hey, I'm in the video conferencing space more or less since ever. Initially on a centralized system, and then the challenge was not enough, so now decentralized in Matrix. I'm working at Element. There in the role as the expert cluster lead, and within the expert cluster, we host all domain-heavy topics like crypto, voice of IP. Nowadays, we call it Matrix RTC. Oh, maybe. Aha, that was a good start. Today it's about Element Call, the first decentralized and federated video conferencing solution. My agenda is as follows. I structure the talk with a brief introduction into a history of calling in Matrix. Then we have a bunch of lessons learned, which then brought us to the point that we say, okay, we need to improve here, and all the lessons learned and nice things on that way went into Matrix RTC, which is meant to be a fabric for each kind of RTC application, and such as a video conferencing solution, and that points me to Element Call. And then we finish off the talk with a sane concept, how we can have guest access also in video conferencing in the Matrix ecosystem. So Matrix, as we all know and love it, is an open network for secure, decentralized real-time communication, and the use cases are manifold. We can talk about interoperable chat. That's basically what we all know. We can build video conferencing solutions on top of it. We can also play around with VR application, and it is also a fabric for IoT use cases. What Matrix is really good at is basically it's an open standard. So a community takes care that we do sensible stuff here and that it will be super cool. It's decentralized and federated such that nobody can break it entirely and own it. That's a pretty nice property. It's replicated and persistent, so even if a home server goes down, the data is not lost because it's shared amongst the whole network. And we default now to end-to-end encryption. And together with verified identities, that's also a super cool foundation for having trusted video conferencing on top of it. But the question is, does it already fit calling requirements? Brief history of Matrix calling. So I think it all started, I was not at that point in time in that company, so maybe Neil, you can confirm, you already started right from the get-go with one-on-one calling, right? Yeah, cool. I think it was at that point David Baker who did the hard work, right? And it was basically pure WebRTC on top of Matrix. But one-on-one calling is nice, but you want more, right? You want to have group calling. But at that point in time, it was quite hard to get it right, and the time-to-market approach was here just to leverage Jitsi as a widget within the Element application. And that's also pretty cool because now we have the widget API, and the widget API also offers a lot of other cool features on top of it. Then back to the roots. Let's make it right and try to get native peer-to-peer group calling into Matrix. That's, again, leveraging pure WebRTC again. I would say it worked okay-ish for up to 5 participants, but we had a lot of issues. We learned a lot during that time. And then in 2023, we were adding a backend to this whole concept, and this now is then the foundation for hosting really large calls. Question is, does it fit the Matrix DNA? So the solutions I already presented. And if you have a look at Jitsi, it's quite clear it was not designed with the mindset of decentralized federation. So yes, it has issue with federation, but you can have large group calls. That's cool. End-to-end encryption, I would say partly it's a bit hard if you want to verify identities here. Interoperability is not a feature which we see in Jitsi. There's only one client, but it does not interoperate with other video conference clients. And it does not fit the matrix permission and role model. And it's also not an open standard. And if you now compare the remaining solutions here, which are all based on matrix, then basically over the time, they fit more and more the matrix DNA. So that's pretty cool. So let's have an interim status here. What we learned so far is getting calls right on matrix is quite hard, really hard. You shoot into your food every 5 minutes. So it's a distributed system, and you have eventual consistency and race conditions, and that is a lot of fun. So what can possibly go wrong if 10 people at the hour press the call button? You end up in 10 different calls. That is not how we want to have it. So typical symptoms in the past include never-ending call ring on your second device, ghosts, split brains, partitions in the call, multiple parallel calls, and the technical term for this is glare. So it's basically similar to people who are speaking at the same time. Nobody understands each other. Unlike to humans, computers are unable to recover. So we need to improve here. And the findings so far are we need to work with eventual consistency rather than against it by adapting to emerging states. That is pretty important. And we need to improve from an application perspective, clear ownership of events and separation of concerns. Because by doing so, we really prevent a whole class of race conditions. And to summarize it in one sentence, it is all about reliable state. Let's face it from the different angle. Does matrix fit calling requirements yet? Decentral, cool. Replicated, cool. We all had this. End-to-end encryption, cool. Verified identities, cool. Reliable RTC room state, that's a to-do. So what can possibly go wrong if you have a network disconnect? Then you're not able to clean up your room or your calling state and this and that. And this is something we need to fix now. From the application perspective, to tackle those symptoms and failures I currently introduced, we also need a lot of improvement on clear ownership, separation of concerns, and adapting to emergent state, such that the application can also, if the room agrees on now, oh, it's a different backend we want to use, then the application needs to be able to switch from one backend to the other, and it should be seamless for the user. And that's a bunch of lessons learned we compressed and took, and we now improved a lot on the protocol level, and we call it Matrix RTC. And the idea of Matrix RTC is that you now have a fabric to build on basically every kind of RTC application. And I also would love to go into detail here because it's really, really cool what we achieved here. A lot of lessons learned, and it works actually right now, quite nice. But we have a dedicated talk for this for Timo. Where is Timo? Here, hey. It will be at 4 p.m. in Lab 4, and I recommend everybody to join it. It's amazing. Yeah, the vision of Matrix RTC, I just give a brief introduction here, is that we want to think beyond calls. Maybe you remember the Third Room project. That was a VR 3D gaming engine that was also based on Matrix, and that could be a potential use case for Matrix RTC. Or for people who were yesterday in the Neo Tool Suite talk from the company Nordec, they have this super cool whiteboard, collaborative decentral whiteboard, and that could also benefit from Matrix RTC. Today, WebRTC is everything you need to leverage to make a video conferencing solution. But tomorrow it might be web codecs or web transport. So it's a key design pattern here that we have a pluggable RTC interface in Matrix RTC. So for now, we have implemented LiveKit, which is a super cool third-party open source project. And they had the idea to make WebRTC developer-friendly. And this is, I can say, yes, it is a super sane ecosystem, and it's really easy to use, and it's very powerful, hence that there's an MSC for that. And the other thing is that you could also go down the path of pure WebRTC and create a full mesh. We did this in the past, We would need to leverage a bit to get it back into matrix RTC, but it's doable. The main motivation why we started this all was basically we wanted to have secure, large calls in matrix. And they need to be interoperable. So that was our vision from the get-go, that we support many, many clients, and you have a base layer defined with a minimum video conferencing protocol, so to speak, that you can, like it is in the telephone world, every telephone can communicate to each other. We want to have the same also on matrix, so that it's easy to make a phone call from Element to Fluffy Chat and the other clients which are all out there. We already saw in the wild implementations, obviously for our Element clients, Fluffy Chat, and also we had a proof of concept with Big Blue Button, which is super promising. Was a really nice project. Matrix RTC at a glance is basically that we followed the design patterns and made a bunch of MSCs around that. So to tackle the clear ownership concept, this is the overarching Matrix RTC MSC. Separation of concerns is handled by the MSC noted here. And one thing which is important for me here to mention is that the mental model here is that the back end of Matrix RTC is alongside each home server, and it's discovered via the home server. So then the distribution of backend or the announcement of backend components is pretty easy to achieve. And then I already mentioned our motivation was we want to get calling rights. So there's an MSC which defines the minimum set of features, of application features, if you want to implement voice and video conferencing. And then as a separate topic, there's Matrix RTC call ringing, because especially in the one-on-one use case, it would be super cool if your telephone also rings. And then one of the important lessons learned on that journey is basically reliable RTC room state, and we implemented it in the home server Synapse, and it's basically cancelable delayed events, which help a lot here. We might see later, and especially in Timo's talk, you really get into the details why this is a cool thing. And the other thing is that we further improved the permissions model of room state. And now I couldn't resist to go into a bit of detail here, because everything is so cool. What we see here, we have two home servers. So we have a federated matrix room. On the left-hand side, we have a client which wants to start a matrix RTC session. And now here is the magic, basically. So we have two state events. One is the join event, where you say, hey, I want to join this matrix RTC session. And at the same time, you also send the leave event in advance. And then you have a heartbeat mechanism to the home server to ensure that you're telling the home server, yeah, I'm alive, I'm participating in this call. And once your browser tab is closed or your network connection disappears or your device dies, the heartbeat stops, and then the home server sends the leave event. And this is important because now we can use entirely matrix primitives going forward to reflect like room state, to reflect the entire UX of matrix RTC-based applications. So matrix RTC is ready for matrix calling. We fixed it on the matrix side, end-to-end encryption, verified identities, and reliable RTC state. And we improved the application layer design as well. And it also supports net-splitted operation. And this is a good question for the Q&A section. So you should ask. Element call. Element call is our vision, how we want to have a decentralized and federated video conferencing solution on top of Matrix. And we cover all call and video conferencing scenarios. So starting with the telephone use case, ringing by default with your DM chats, basically. We want to have ad hoc in-chat calling. So if you have a room with your buddies and you're hanging out regularly, that is the right place to start a call. Ringing here is then part of the notification settings. You could escalate it to, yeah, please ring. I really don't want to lose this call here. Or there's just a notification toast that you at least are aware and have a notification. And then the classical one, which is basically following the habits of all the people, that is the conferencing, the standalone scenario. So nowadays, if you're attending a video conference, your call starts in the calendar app most of the time. You follow a link, and then you are in the meeting. And since this is the habit of the people, we want to change it, but it's the habit of the people. We also want to support this in a sane way. And this is also the solution where we also have then a proper solution found for guest access, but we see later. Again, I mentioned element call is federated and decentral. And for me, it's really important now to spend some time here to explain that this is very different from how video conferences are working with a Jitsi link, a Zoom link, or whatever. So the mental model here going forward is, and you see it on the left-hand side, we have here 3 home servers, A, B, C. We have 2 back-end systems deployed here alongside home server A and C, and we have a bunch of clients here in the green bubbles. And the idea is, in the ideal world, that alongside each home server, you have an SFU. We have here an exception at B, and we see how that propagates down. And the SFU, which is alongside the home server, is meant to serve all rooms which are living on that home server. And that obviously includes also federated rooms. Let's make an example and start with this arbitrary room here, 456. Here we have participants from 2 different home servers, home server C and home server B. And it's quite clear in this example that they are using the SFU from home server C, because home server B doesn't have one. And that has an implication. The folks from home server B, they can join a call, but they can't start one because they don't have an SFU. And if we have a look at the other room here, 1, 2, 3, we have 3 different home servers involved in that room, or participants from 3 different home servers. And then there's an election algorithm which eventually is consistent. And here SFU A is selected. But if it would choose to SFU C, that's not the end of the world, because the application is designed in a way that it adapts emerging state, and then it would just hop from the one SFU to the other one. And this, on the statistical average, ensures that we have a fair distribution of backend resources in this federated network. That's cool. One word about the SFU we are using. I already mentioned we are using the LiveKits interpretation of WebRTC. And there are a lot of batteries included. And I want to go through one example here. When we talk to customers, it's quite often that they are asking us, or if you use an SFU component, then you would need a lot more network bandwidth compared to an MCU concept, where basically all video streams are rendered on a server, and then you only transmit one rendered stream to the participants. But that is not true. So if you start it in a smart way, and we now explain you in a minute how that works, you are around about the very same network bandwidth you need to use in an SFU scenario compared to an MCU scenario. And we see it how it's worked here. So on the left-hand side, we have subscriber video tiles. So that is basically on the UX layer on your video conferencing application. And depending on the video size tile, you're requesting through the SFU from the publisher a different quality level. And the example here is that the first video tile is a low quality, a small thumbnail view. The second tile is interesting. That's basically out of screen, it's invisible. So in that case, we really don't need to download that media. And the last one is a medium one. And since the protocol is smart, the SFU propagates this information back by quality updates, and the publisher knows which media it needs to send to the SFU. Yeah. And if you combine this all together, you have really a network bandwidth which is extremely comparable to only one big high-quality video stream. It's even better, to be honest, because if you background your video application, you only transmit audio. So then is the next question, what about scaling? So if you have a current machine in a data center, you can host up to 500 participants. And here, these are participants with HD video streams on a single machine. And that is basically the limit of one video conference size. Horizontal scaling, we are just using industry standards here. You would use Kubernetes. So that's more or less very low hanging. Next question is, so how do we get element call in messenger applications? Element call in the early days when it was research and development was developed as a single page application, so a web client. And now you have basically two options, quite easy. You could re-implement it natively on the platform, which is web, Electron, desktop, whatever, and mobile, it would be Android and iOS. So you would, in the best case, have 3 different implementations. On the plus side, you would have a native look and feel, but you would need to re-implement element call from scratch. And you would also have 3 times maintenance on each of the individual implementations. The other approach is, which I pitched very early, I think on the second slide, is that you go widget approach. And a widget is basically a web app living in a matrix client. And via the post message API, this widget is able also to use matrix primitives like to device messages, room state, and this and that. Here we would have one implementation fits all. Web browsers, using a web view is using a web browser, uses more or less the most advanced WebRTC stack, and since they are used on an everyday basis from a lot of people, they really take care that the WebRTC stack is every time in a good state. And time to market would also benefit from this. However, it would require a widget driver on each platform. Luckily, we already had one on the web side of things, so we just needed to develop one on the Rust SDK side of things. So let's use a widget. I think that is, after having those options in front of us, I think that is the obvious approach. Okay, now we are back to one implementation fits all. And in standalone mode, it's just behaving like a regular matrix client using the client server API and speaking directly to the home server. Check. And in widget mode, you have basically element call living in a widget within the underlying matrix client. And here we see we have an example for a desktop client and also an example for a mobile client. Now we solved that we have the actual video conferencing running. But the actual video conferencing is not enough because you also need some signaling around it. You want to have it ring notifications and this and that. And this is nothing you could have living in a widget. You need it in the underlying messenger application. And in our case, Element Web and Element X. So, and now we have, again, the very nice property and then the design pattern of matrix RTC that basically everything is just a room state. And you need to map or can map room state to exploit most of the features. So here we're leveraging the MSC for matrix RTC ringing, call ringing, and we configured we developed our implementation this way that we use ringing in DMs, and we use notification toasts in large rooms. And on the Element desktop side of things, we also introduced a new video room concept, and this just has a video first UX. And in order to find easily your next upcoming video conference, we added a meta space also to the sidebar, which is basically a filter for video rooms. And then if you want to create a new video conference, the idea is that you every time create a new video room. We will see this in a demo later. And then on the Element X, on the mobile side of things, you want also to feel it like a native application. And hence we are using the native call kit integration for ringing and notification. And this is a very deep integration. So we also have the native dialer implemented. So if you go to the recents list of your native dialer and you click on a missed call, it's elevated back into the application element X, and it will automatically start the video conference. And of course, it has picture-in-picture mode. Yesterday, we all saw this already in the Element X talk from Amadine. So if you haven't seen it, I really recommend to go through the recording. And the community is contributing. That is pretty cool. So recently, it started that people are using Element and Element Call. And also in our community channel, a lot of people are started self-hosting Element Call. This is pretty cool news. And where is he? Johannes? He added QR codes, link sharing to Element Call, and some other nice features like removing calls from a recent list. And we finally have initial support for raise hand feature from Milton. Where is he? Ah, I see. Okay. Maybe we should call him. Yeah. So now, what have we solved? We have 3 different flavors of Element Call and different embeddings. So we have a conferencing mode where you just need a web page and you can join a call. And we have the deep integration into the messenger applications. The last missing bit is to interconnect both worlds. We have the video conferencing solution and the deep integration in the messenger. And this is where guest access comes into the play. And this is how it works. Matrix, and this is because of the federation and one of the superpowers as well, allows separation of guest users quite easily. Because what we just need is enough home servers to separate guest users from your main home server. And a call is, of course, a matrix, everything is a room. A call is happening in a potential new matrix room. So we don't have guest users on your main home server. And on this specific guest user home server, you have temporary accounts which are created on the fly. You could also have account retention possibly configured. And the important bit is that the user experience is frictionless. So the user, if they want to join a call, they literally just have to provide a display name, and then they can immediately join the call. Yeah, and we connect to the home server via federation, but this we already had a nice example how this works. Now you're asking, obviously, is this secure? Is this also from a user perspective? Do they feel that it is secure, and is it secure in the real world? And we choose that we are using the knocking feature here, so that every guest user can only join that room if he knocks to that room, and then someone needs to be at the same time in that room and grant permissions. And here we're basically just using matrix primitives, and we align them, we put the dots together in a smart way, and really have a nice framework how we get the standalone conference use case combined with the deep integration into the messenger applications. And I think now it's time to make a demo. One disclaimer here, I learned that the Wi-Fi here only serves IPv6 today. So if you want to join the demo, it would be a good idea to use your mobile network. So everybody has enough time to scan, and then let's see what can possibly go wrong, right? Okay, there are a lot of people asking. Oh. Oh. So what we now can see here is that basically all of you are using the conference mode where you just have a web page. And here I have the deep integration into the application. And if new people want to join, it's so kind that my colleagues, which also have the same application, grant the knocking request. I need to switch that off a bit here. Yeah. Thanks. Ich verstehe. Okay. Yeah. Okay, here we are. But there's other feedback in the room. Yeah, maybe I should.
Nicht das Mikro. So people in the room can't have the mic open. The sound is going to be in the room. So only people that are not in the room can have the mic. Not in this physical room.
Yeah, can you please mute all your audio? Then we should be safe again, and I can walk you through the features here. So first of all, what we are noticing here, that we have this share link button here, and this basically just creates the link, the QR code which you used in the previous slide. So that's how easy it is to create a guest access link. Then we have a lot of people joining here. So how many are we? It's 16. And now we can do some experiments. So if someone please here could just kill the web browser. Maybe Andrew is happy.
I did.
Okay, cool. Maybe I demonstrated in a separate thing. So what basically happens is that we could demonstrate now reliable state, and that gives you, if you just kill the session, then you would see that the counter here will decrease. Let's see. Maybe we make this now in a follow-up with maybe with Timo. We demonstrate it in a minute in a different room here. But what I can show here as well is that we have, as you know, these two nice view models where you have the grid mode and just see everybody here. But if someone starts a screen share, then it would automatically switch to screen share mode or to the spotlight mode here. So maybe someone from the Void team can just start screen sharing. Not sure if they got it. That's how it is with live demos and restricted internet here. But you see at least the UX layer. So in theory, we have here a nice screen share experience, and you could also maximize it to make most of it. And maybe a different one can also start a screen sharing. Then we can also see that you can have multiple screen shares at the same time, and maybe the next screen share also works. Or did work. Yep. Now we have it. Thanks. So now you have a carousel here, and you can have multiple screenshots at the same time, which is sometimes a nice feature, more considered as a power feature. And if I that person is not talking. Yep, it's okay. And you also have a nice indicator here in the bottom, where you basically see how many screen shares are taking place. Yeah, so this is the one demonstration I wanted to make, but obviously we also all want to see the native call kit integration, and that's the next demo I try. 10 minutes, including Q&A? Okay. But everybody wants to see the native integration. So I start. And now, Timo, I think it might be a good time to start it. That's how it works. Hey, Timo. Yeah, and if I now go back to the native, you would see Timo called me, and if I press it, then we are getting back into the application, and Timo is called back. Does it ring?
Yeah, I was still part of the call.
Ah, okay, I see. Yeah, okay. No, but it works as expected. No risk. Okay, and with that, I conclude my talk.
It was including.
Including Q&A, 10 minutes. So how many minutes do I have left?
8.
Yeah, it's okay. Let's be fast here. Summary. Matrix. Oh, come on. That one. Matrix RTC is ready for calling. We are using matrix primitives such that the client UX is just mapping room state. That is pretty important. The element call widget implements the MSC for the base layer of video and voice and video conferencing applications. And we have a very deep integration into our native element X applications using call, click, and picture. And we have a frictionless solution for guest access. And I really want to thank you, the whole VoIP team at Element, because it was really a lot of fun and a really nice working environment to get this all sorted. And now we see it in practice, and that's pretty cool. Thank you.
Thank you, Florian. There's a question from the speaker. How is the element call handling net split situation?
Ah, that is a good one, but it's a tough one. So I think there's, in this picture we can see it. So let's say in the talk with room ID 123, that is basically this talk here, you would have a net split between A and, it's not so interesting, between A and C, then basically the people from home server A would use SFU A, and the person on home server C would use the SFU and C. And if the net split would, this is carried out by home server presence. So basically, you know, oh, if the other home server is offline, then I need to partition it. And within the sub-partition, then you can again agree on a new SFU. And if the net split is recovered, then magically everything recovers again, and you agree on the same SFU, and everybody's in the same call again. Yeah. Other questions?
Thank you. Other questions? Yeah.
Hi, thank you for the talk. The question for me is, can we integrate element call with other type of VoIP solutions? So would it be possible to make an integration where somebody's on a Twilio or some other kind of a cloud VoIP system that can make a call? Would it be some type of bridge? What is the...
Okay, so basically...
What kind of scenarios can you have where you have communication with other systems?
Yeah, so interoperability across, beyond matrix, not across matrix. What you would need is basically a gateway. It's doable. So basically you would have a domain gateway, which on the left-hand side would speak matrix RTC, and on the right-hand side, whatever tag it should be you want to bridge into, and that is how it would work.
But it would work in a similar way as a bridge?
Yes, you need a bridge. But this is obviously then breaking end-to-end encryption, right? You would terminate the end-to-end encryption on the bridge, and then bridge into the other network. Yeah.
Okay. Thank you.
Thank you. Any other question? Oh my God.
Hey, sorry. So might be a stupid question, but I just wanted to understand. You say SFU along each home server.
Yeah.
So what if I have 3 home servers federating with each other?
No,
and one of them doesn't have.
No. So if, let's say, if you have a very powerful SFU cluster, you could, via the well-known configuration of each of the home server, you can just point it to one. That's fine.
Okay.
We also had this example here, right? So on home server B, there's no SFU, but the well-known configuration of B could advertise the SFU cluster from A.
I see. And so I'm just still trying to understand the guest mode. So for example, I want to invite, say, for example, a person who is not on Matrix network to talk to. Then in that case, the guest mode that you're talking about, does that work, or how does it work?
How does this work? You would go into your, let me show it, in your Messenger application. You would start a call. Let's see how many people are all there. And then you have here this share link button, and you just would use this link you shared, and then you type it in your web browser. You just give your name, hello world, and you would join. You need to grant access, and that's how it works.
Yeah, just one quick question on top of that is, so suppose you as a moderator end the call, so it ends for the other person as well. But
sorry, I didn't get that.
So on the left side, you are basically opening the call. And on the right side, we have the guest.
Yes, right.
So if you end the call on the left side, it probably ends for the other person as well.
No. You need to, if you really want, you need to ban that person. Then you would go to the room list and say, I really want not to have them in this room again.
Okay. And what happens when you are not in the call, but they click the link first? They get into the waiting mode? Or?
Yes, they basically are in the waiting state because you need to approve the knocking. Yeah.
I understand. All right. That's all. Thank you.
Cool. Welcome.
Any last question? Yes, I can see a hand over there.
Basically, I have two. The one is, what do you thought about abuse? So we can just have a home server A with an SFU and a home server B that is kind of malicious and just points the whole traffic to the A SFU. How can I moderate such kind of things?
So the idea is that you only would have video conferences in private rooms?
No, just if I have a malicious home server B that just tries to steal bandwidth or resources from home servers A's SFU, can you limit that?
Yeah, right. So the idea here is the following: and we didn't show this here in the slide deck. If you want to join a call, you're asking your home server for an OpenID token. With that OpenID token, you go to a service which grants you a JWT token for the SFU. And this service can ask your home server, is that person on that home server? Yeah. But it's then limited to all users which are known by that home server.
Yeah. So, and the second question is, you pointed out that the SFU tells the clients what they should send. Also, this address to advertise multiple quality resolutions, like if you, for example, have a call where you have different participants that resize different windows. So it's doing that, or it can just advertise one size.
I didn't really get that, sorry.
One call.
Yeah.
And you have 3 participants, and one does have a full screen, the one partition, and the other has the other one full screen. Does it work in the UX? And does the backend account for that? Or is it just...
Yeah, that would work. Yeah.
Okay, yeah, thanks.
Yeah.
Okay, and we have a very, very last question.
Sorry, I don't want to steal it again, but you mentioned that you support 500 participants for 4 core and 8 gigs kind of system. I just wanted to check how many with video on and how many with video off.
That is everybody with video.
Everybody.
That is an edge. That is an extra edge experiment. So you wouldn't have a call. That doesn't make sense. Your client would explode because you can't present 500 HD videos.
Yeah. Okay.
Yeah.
Okay, thank you very much, Florian.
Thank you.